Good afternoon, everybody. So today we are going to see about the subject protection and switchgear. It's a power stem based subject. What are the topics here in protection and switchgear? In Unit 1, importance of protective schemes for electrical apparatus and power stem. So various schemes of protection. The review of faults and fault currents. Already we studied about the fault and fault current in power stem analysis. And the relay terminology. So relay is the protective device. Various definitions involved in relays. Essential qualities of protection against over voltages, that means due to lightning and switching, arcing grounds. Then the Peterson coil and ground wires used for the protection, surge absorbers, diverters, then earthing. In Unit 2, we have the operating principles of relay characteristics, generally the electromagnetic relays, in which we have overcurrent, directional and non-directional, distance, negative sequence, differential and under frequency relays. In Unit 3, various apparatus involved in the protection of the system. So in which we are going to protect the transformer, generator, motor, bus bars, transfer lines, CTs and PTs. Then in Unit 4, theory of circuit interruption, how the circuit is being interrupted. The arc phenomena, mainly the arc phenomena, DC and AC circuit breaking, the various technologies, restraining voltage and recovery of voltage, rate of rise of recovery voltage, resistance switching. These are all about theory of circuit interruption. Then Unit 5 discusses about circuit breakers. So mainly different types of circuit breakers. Air blast. So based on the medium used, we have air blast, air brake, oil, SFC and the vacuum circuit breakers. So starting with the power stem basics. So power system is a system of generation, transmission and distribution. So we have generation, transmission, distribution to the loads, various components involved in the power system. So generators, in transmission we have primary and secondary transmission. Here we have the transformers. Then the distribution. After the transmission we have distribution involved by different transformers, step down transformers. Then various distribution lines connected to the feeder lines to the loads. Up to the loads we have the power system, electric power system. Single line diagram, representing power system in a single line diagram using various components and their relative circuit diagrams, circuit symbols. We can form a single line diagram for the power system. So first unit, protective system, importance of protective schemes. Various symbols involved in the power system components. Here we have all the components starting from 280 transformer to generator, bus, transmission line, various connection of the lines, delta and Y connection, then the symbol for static load. Then primary equipments to be protected, transformers, we have step up and step down transformers, breakers. So what's the importance of the breakers? It is to energize the equipment and interrupt fault current to isolate the faulted equipment. So with the breaker use only, we can isolate the faulted equipment. Insulators. It is to insulate the equipment from ground and other phases. Isolators, normally the switches. It is creating visible and permanent isolation of primary equipment for maintenance purposes. Bus. What's the definition for bus? It is to allow multiple connections to the same source of power, mainly the transformer. Grounding, to operate and maintain equipment safely. Arrestor, lighting arrestor. Switch gears, it is the integration of components to switch, protect, meter and control power flow. So all functions are involved in switch gear. Reactors used for limiting the fault current. Series as well as shunt current. VT and CT, the transformers for the measurement of current and voltages. regulators, so for measuring, controlling voltage, current, the reactive power, and also the phase angle. Why a system needs protection? So we should maintain a fault-free system and also ensure safety of personnel. How the faults are created? Faults are caused by breakdown of insulation. It's insulation failure due to various reasons. That is due to overcurrent, over voltage, or lightning. These are all the causes for fault. So in these faults, from these faults, we have to protect the system. In that way, we need protection for the system. We need the power system components. Protection system. It is a series of devices whose main purpose is to protect persons as well as the primary electric power equipments from the effects of faults. So various characteristics and the main causes. Loss of service in a large area of population region. Assault to human life. It may result in enormous economic losses. The main causes are overreaction of the protection system, the bad design of the protection system. So protection involves circuit breakers and the relays. Relays are energizing the circuit breaker whenever we have the fault in order to isolate the components of the system. So after the clearance of pulse, we have to reclose the circuit breaker. That is also involved by the relays. The main purpose of protection element, we have the relays and circuit breakers connected with the relays. So energizing the circuit breakers or operating the circuit breakers, the relay is involved to isolate or reconnect the faulty equipments with the system. Power system without protection. So without power system, the short circuits and other abnormal conditions often occur on the power system. Due to the load variations, we have the abnormal situations always possible to occur. The heavy current associated with short circuits is likely to cause damage to the equipment. So creating the heat effects, it is always a cause for damaging the equipment. So what are the various elements in the protection system? Current and voltage transformers for measuring current. When sensing the current and voltages, it will be giving the current and voltage outputs from the transformers. Relays, so mainly actuating the circuit breakers. Relays, circuit breakers. Circuit breakers is used to break or reclose the element which is being affected. Batteries for energizing purpose. Fuses involved for the primary protection and also lightning analysis. So main elements of protection. Current transformers. So current transformer consists at least 2 secondary windings. There are 2 secondary windings. So where we have compared the outputs, two outputs. The first winding is usually designed for measuring. The second is also used for the protection. So having 2 secondaries, we have current transformer. Then voltage transformer. It is also for the measurement and also voltage transformer is often consists of 2 windings. So first winding is connected in star. The second winding is connected as open delta. So voltage transformer. Relay purpose isolates the controlling circuit, control high voltage system and also high current system with logic functions. Advantages for using protective relays. What are the advantages? It detects the system failures when they occur and isolates the fault section, mitigating the effects of failures after they occur. So not only identifying the fault, and also it is involved in the mitigation of the failures, and also it is minimizing the risk of fire, damage to personnel and other high voltage systems. Circuit breakers. So the types are low voltage circuit breakers. So applied in the low voltage circuits, magnetic circuit breaker, medium voltage circuit breaker and also high voltage circuit breaker. So based on the level of voltages where we are using circuit breakers. Battery bank. The battery bank are called as backbone of protection system. So since it is involved in a backup, so backbone of protection system, So emergency use for power system. Fuse. Fuses are selected to allow passage of normal current and of excessive current only for short periods. It is used to protect the low voltage or current devices. So like the circuit breaker, it is also connect or disconnect the system with the supply. It is normally to protect the low voltage and the current rating devices. Low voltage or low current rating devices. It is also a protective device for low current appliances. Lightning arrestor is a device used on electrical power system to protect insulation damaging effect of lightning. So due to the insulation damage, we have to protect the system from lightning. Switchgear. Switchgear is the combination of switches, fuses, circuit breakers used to control, protect, and also isolate the electrical equipment. It is used to de-energize the equipment and clear faults. So during the fault, it will be de-energizing the equipment. After clearing faults, it will be automatically energized. The equipment will be automatically energized. What are the various elements? Circuit breaker. In circuit breakers, we have low breaking switch, bypass and changeover switches, isolators, fuses. Different type of circuit breakers are air circuits, vacuum, oil field, and SF6. And MCCB, MCB, and RCCB, various type of circuit breakers for tripping purposes when we have faults in order to trip the circuit. Function-wise categories. So they are automatic and manual operation. Circuit breaker, MCB and MCCB. During the faults, automatically they will open or reclose circuit breakers. Fuses are automatic operated. The manually operated are isolator and LPS. According to the voltage levels we are using, we have different type of switchgear. Low voltage switchgear, that is up to 11 kV. Medium voltage switchgear up to 66. High voltage up to 66 to 400. Up to 400 kV. We are using high voltage switchgear. Extra high voltage switchgear are used for the voltage level of up to 765 kV. And beyond that, extra high voltage and ultra high voltage, we are using the HVDC switchgear. Fault and fault currents. What are the causes for faults? So it may be due to the insulation failure, the insulation over the conductor. If it fails, we have the fault. Conducting point failure. It may be opened or short circuiting. So due to that, we have conducting point failure. And also creation of over voltages into lightning and switching surges. They are also creating the faults. Puncturing or breaking of insulators. That will be creating the short circuits. Failure of conducting path into broken conductors. Failure of solid insulation. These are all the various causes of faults. Normally faults are opening of conductors or short circuit between the conductors or damaging of the conductors. Fault in power system. The power system fault may be defined as any condition or abnormality of the system which involves the electrical failure of primary equipment such as generators, transformers, busbars, overhead lines, cables. So in all components we have the failures that will be defined as faults. So classifying the fault, we have two types, symmetrical and unsymmetrical. Faults giving rise to equal currents in lines displaced by equal phase angles. So in all the cases, we have the energization of equal currents. So that is categorized as symmetrical fault. So in three-phase, symmetrical fault. Example, short circuit of all three-phase conductors of a cable at a single location. That are categorized as three-phase faults. The other name for symmetrical fault is three-phase faults. So unsymmetrical faults. So here the line currents are not equal. The fault currents are not equal. In all the phases, they are not equal. The faults are categorized as single line to ground fault, two phase to, that is line to line to line, double line to ground fault, or line to line fault. So various abnormalities in the power systems due to the faults, which are creating the disturbances in the system. So line to ground faults, double line to ground fault, that is short circuit between any two lines. three-phase faults, or two-line to ground faults. Symbolically, we can represent the various faults. Then the frequency of types of faults, which based on the occurrences. So the major percentage of occurrence of fault is due to single line to ground fault. So 85% are of single line to ground faults. That is the short circuit between single line, any one of the line with the ground. So it is about 85%. Line to line fault is about 8%. Double line to ground fault is about 5%. Then three lines. So it is about 2%. So the major possibility of occurrence of fault is the fault due to the single line to ground fault. It is about 85%. So equipment. Each equipment is mostly affected by the fault occurrences. So it is overhead lines. It is mainly affected 50% of the fault occurrences and the overhead lines. On cables it is only 10%, switchgear 15%, transformers in the transfer lines it is about 12%. CTs and PTs in the lines they are affected only by 2%. Control equipments are 3%, others are about 8%. So mainly the main component which is frequently affected by the fault is the overhead lines. Symmetrical faults and three-phase faults. Unsymmetrical faults we have different types. And also breaking of the conductors. That is categories open circuit faults. Single phase open circuit or two phase opening of any two of the lines or all the three phases. So various equipments and how they are being affected by the faults. Transformer, it is due to insulation failure, faults in tap changer or overheating. Current transformer and potential transformers, they are affected by over voltage, insulation failure, break of connectors and wrong connections. Non connections is also causing fault. Symmetrical components using which we can analyze the unbalanced system. Fault minimization. So by improving the quality of machines, equipment, installation, and also by improving the design techniques, we can minimize the fault levels. Adequate and reliable protection system control. So by using protective systems, we can minimize the faults, maintenance, and also effective management. Merits of fast fault clearing. So it avoids permanent damage to equipments, reducing the chances of risk, maintains a continuity of the power supply, and also bring back the power system to the normal state sooner. Relay terminology definitions. Various terminologies involved in the relays. So how to define relays? Relays are electrical switches that open or close another circuit under certain conditions. So during faulty conditions, it may be opening or closing in order to connect or disconnect the faulty components. So with this we can conclude the introduction of protection and relays, how the faulty conditions are created using the protective devices, how we can overcome the abnormal situations.